Let us see together how we can conduct some network measures for quality of service, such as latency, which is the delay in buckets, as well jitter, which is the delay variations in the bucket. And so these measures are quite important to identify the quality of service in the network, and it also gives us indication of which applications will perform better in this network. So probably Bing, it's a most commonly used tool in this purpose, and almost it comes in with all operating systems. So basically, when you start, we can use, for example, Bing to Bing any host in the internet, let's say st.st, or if something like that. So it will grab its IPv6 automatically, because the post site support IPv6, so it will use IPv6 automatically. Otherwise, we can look at for example the associated IPv4, and then we can bring it specifically. Then we can get information. So what kind of information we get here? We get the timestamp here, the time, the TTL here, which is indicating the time for the bucket to travel from this testing machine to the SDNOC server and come back. So that's quite high. It's 300 something milliseconds. And then we will have here some small report showing that what was the situation here. Like we have sent 6 packages and we received 6 packages, and as well there's 0% bucket loss. So there's no bucket loss in between. Good. So I'm going to focus specifically on IPv6. I'm going to conduct everything based on IPv6, but it is applicable also for IPv4. Well, there's other tools, not necessarily Bing. There's other tools, very nice tools that can provide nicer report to give us better view and visualize the data, like MTR, for example. MTR, for your information, if you are using Ubuntu, you can install MTR by sudo apt install MTR, and then it will be installed automatically for you. So MTR, and then we give the host name. Let's say I'm going to focus only on the IPv6 associated with, for example, let's say my machine I'm going to test is Google. So MTR, it looks nice, and it gives us a beautiful output that we can go through it to read the indicators. Let me look if I can drag this a little bit, if you can see that. Yeah, perfect. So what we can see here, the number of hubs, we have about 12 hubs between my source, between my testing machine, until I reach there. And there's continuous measures happening around here. You can see that here, how many buckets being sent, and then whether we have bucket loss per hub. But it's quite good link, so there's no any bucket loss in between. Also, it gives us the last measures that we have, the last latency recorded. Here the average latency. Here's the best latency. It means the shortest time for the bucket to travel from to the source and destination. Worst, it means the longest time, as well the standard deviation based on the measures collected here. So I think that's quite enough for us to identify what kind of network we have here, and what's the quality of the network that we are currently use between the source and destination, as we can see here. Okay, what else we can use MTR for? What kind of other things we can use MTR for? So we can use, for example, if I want more information, for example, MTR having the same command actually we can use, but rather than the names or the BTR records, I need the numbers. So I can put -n to indicate the numbers. So you can see here all hubs, it's written in a pure IPv6 without naming. So sometimes we need that. And as well, we can list down the AS number per hub. Like for example, this IP address belongs to this AS number, and this IP address is originated by this AS number, and so on, until you reach the last destination, which is Google IP address. So MTR can provide more information and can visualize the result in a nicer way. And this kind of report is live report, but sometimes we need an offline report. So offline reports means send number of buckets, collect the measures, and print out the reports for me. So if we need that, we can just add another option called -r to indicate report. So it will send some buckets to the background, and then at the end of the time I'll get the result with all measures that being collected during the test period. Let's see what kind of measures we have here. Well, so there's 10 buckets being sent, and this measures collected from that 10 buckets, and that's good for us to have it as a last report to indicate the quality of service in our network. Well, so now how we can go through the same tool, but we can test jitter. For your information, jitter is the variation between buckets, and it's quite sensitive for applications like video conferencing, or we can call it inelastic type of traffic that's sensitive to time. So it's quite important for streaming protocols, or voice or video and so on. So how we can measure the jitter variation, for example, between my server using IPv6 network. For example, I want to look at the jitter from my server, for example, to nav6.org server, which is hosted in DigitalOcean. So as you can see here, we can see this is the jitter variation, which is below 0.0 something, so it's quite low. That means the quality of the network is good, and we are able to send and use it. We can use this network for real-time applications with high performance, and the quality will be really good. So, and also we can collect, for example, the only for example, I want only the jitter, and also I want the actual jitter, and also I want the average value collected out of the numbers of out of the tests, like the number of tests. So it will continue sending buckets and keep testing, and we can see the last column here indicate the average value of the jitter. Sometimes we need the average value to, if we conducted number of tests in long time, then we need to look at the average value. It can give us good indication of how the network look like. Also, we can add to that the worst value as well by adding x. I think we can add x capital. That can give us the actual jitter. The second column is the average, the last column is the max. It means the maximum average that been recorded during the test. Well, I think I've done now with the delay, which is latency, known as latency also, and packet loss as well, the jitter. And now let's go through bandwidths. And bandwidths actually is the maximum data rate that can be transferred across the specific link. So how we can do that? There's other tool can be used for this purpose. We call it iperf. It's a standard tool, iperf3, and I need, for this test, I need 2 machines to do my tests successfully. I need a server, and then I need a client on the other side, and whatever I'm going to collect, it indicates the measures between this server and this client, not necessarily the rest of the network. So how to run the server? I'm going to run here. The server is just iperf3-s. So the server is listening in a default port, which is 5201. So I need to grab another terminal for my client, as you can see here. If you can see here, okay, this is a client. So what I should do here, or what I should perform here is to use iperf tool, because it's already installed here. So iperf, I'm going to use iperf3 and then connect to the server. So what is the server IP address? This is the server IP address. So it will start sending number of buckets and collect the bandwidth measures that been conducted during the let me show you how the result look like. So this is the last result that I have. It shows what was the bit transfer and all of this information. This is what was sent and this is what was received. So that will give us also how the bandwidths look like between my client and this server. So that can give us indicators how the things work. Also, I can conduct the same measures, but pretending as, for example, multi-threading, like 2 or 3, for example. You can send like three requests in the same time. It looks like there are 3 clients in the same time conducting measures, so that can give us different readings actually. So the first sender receives belong to the first thread and the second thread, and this is the third and the fourth thread as well. This is the submission actually. This is the submission of above to indicate the all overall measures. And by default, iperf will use TCP, but we can also conduct measures using UDP for the same thing. So I need to come back to the server here to clear and I need to add more options here, like iperf s and then indicate u. It means UDP, and then I have to go back here to my client and then perform different same actually. Just I need to add here -u, same command, iperf -c, and then the server IP address space -u. Then we will use UDP instead of TCP. And the difference here is quite known, I think, for those who are involved in network, because UDP got no orientation and it just send the bucket without any connections. There's no connections in UDP. So same, we have a nice result here for sending and receiving that can give us indicators how our network will behave if I send buckets over UDP. Thank you.